Hello everyone, welcome back to Marin Maths. And well, I was not posting any videos for the past few days because my vocal cords were temporarily unavailable, due to some common cold or some flu virus that I got. It's actually pretty spread around the university, so a lot of people are sick right now, but it's not coronavirus, so don't worry about it. It's gonna come later, so we shouldn't worry about it too much soon. But of course, you gotta watch out for that now that we know it's in New York City. Anyways, some housekeeping, guys. So for the common exams coming up, I'm going to do a review for common exam number 2 for differential equations and common exam number 2 for physics 3 or physics 234, which has to do with waves and oscillations. So yeah, that's all. But today we're going to go over something very important. And you know what it is? Well, it has to do with sine, cosine, and tangent, or at least that's what they told you it was pronounced like. But today I'm going to teach you the right pronunciation of these trigonometric ratios, because you have been saying them wrong your entire life. Okay, so over here we have a very familiar figure. This is the unit circle, right? It has a radius of 1, okay? And over here we got the composition of one of the radius. Over here we have a y component and an x component, right? So if we assume that this over here is 90 degrees, then we know that for a fact, by the Pythagorean theorem, x squared plus y squared equals to 1, right? That's a given. But now let's say that we give this triangle an angle theta, okay? So this over here is theta. And then we can say that sine of theta, now here is the thing. This is not pronounced sine, this is sinus. So this is the actual pronunciation. So sinus, let's write it out. Sinus of theta is nothing but opposite over hypotenuse. So over here our opposite side is y, and the hypotenuse is 1. So y over 1 is sinus of theta. Now cosinus of theta is nothing but adjacent side over hypotenuse. So it's going to be equal to x over 1. Okay? Now we can take advantage of the Pythagorean theorem to arrive to the very first trigonometric identity. So if our x is cosinus of theta and our y is sinus of theta, then we can say that cosinus square of theta plus sinus square of theta equals to 1 squared, right? And then from this we can derive other trigonometric identities. Like if we divide everything by cosinus of theta, then this over here becomes 1, right? And this over here becomes sinus, this is sinus squared theta. And this over here becomes sinus squared theta over cosinus squared theta, which is nothing but, not tangent, no, it's tangere. Tangere of theta squared. And that's nothing but 1 over cosinus squared, and 1 over cosinus squared is not secant, it's secare squared of theta. Okay, so that's one of the identities. So 1 plus tangere square of theta equals to secare square of theta. Now, we can arrive to another identity if we divide the original identity by, instead of cosinus square, we can divide by sinus square. Okay, so let's divide everything by sinus square theta. Okay, over here we get cosinus over sinus is cotangere. Cotangere of theta squared plus sinus square over sinus square is 1 equals to 1 over sinus square theta, which is nothing but, not cosecant, cosecare. So it's cosecare squared theta. Very good. So here we have arrived to the very true 3 trigonometric identities that can help you resolve any trigonometric problems. So yeah, this is the right way to say, your trig ratios. So cosinus, sinus, tangere, secare, and cotangere and cosecare. Okay, So this is the basics of pronouncing your trigonometric ratios. Okay, so that's good. I hope that this was helpful for you. Hopefully from now on you're going to start pronouncing this trigonometric ratios the right way. Okay, spread the word. Make sure that your friends know about this so that they can they stop mispronouncing the trig ratios. No longer sine, cosine, or tangent. It's sinus, cosinus, or tangere. Okay, so thanks for watching, and I'll see you next time.